So in the previous section, we looked at how angles interact with circles. Now we're going to look at how segments interact with circles, specifically their lengths. And we're going to do this we're going to start off looking at it from a proportion standpoint, since that's what we're used to, and we've been working a lot with proportions ever since chapter 8. So let's look at these segments that are created by these two chords intersecting. And what we're going to do is kind of break it up into, they're not really triangles, they're called sectors of a circle, but we're going to treat them like they're triangles, okay? So let's say I've got, if I can trace this a little better. Okay, I've got this blue piece here, okay? And then I've got the red one. It really doesn't matter which way you go. We could have picked the other two also, right? We could have picked this one and this one. We're just going to do these. Now, if we said that these were similar, then we could set up a proportion. Okay, we would say that CE, okay, corresponds to this because they're on the same one together, right? So we'd have a constant ratio between CE and AE, and that should equal the same thing as, okay, so since CE was on this top part, we're going to put BE across from it. And then we're going to put ED underneath it. Now we cross multiply, what we end up doing is multiplying CE and ED. That's this and this. Okay, so the two pieces of the chord are going to get multiplied together. So CE times ED would equal AE times BE. Okay, so instead of setting proportions every time, we can make a shortcut. And we're just going to say piece times piece equals piece times piece. Okay, and these two are from one chord, and these are from the other chord. Okay, so I'm just going to say CE times ED equals BE times EA. This piece of this chord times the other piece of the same chord equals the two pieces of this chord multiplied together. Okay, and that's how we can solve. So, you know, if we have a missing one, you know, if this was 5, 4, 2, and x, okay, that would mean that 5 times 2, 10, equals 4 times x. So that means x would be 2.5. Okay? Now, it's kind of like when we were talking about angles, how we just had one formula for two chords meeting, and then we had one formula for these three situations, for two secants, a secant and a tangent, or two tangents. It's the same thing here, but we're going to have to think in more general terms, okay? The general rule is the outside piece times the whole thing equals the outside piece times the whole thing. Okay? So we've got two secants. I could say that EB, which is the outside piece, times the whole secant, times the whole thing, which would be EA, should equal the outside piece of this secant, ED, times the whole thing, EC. Okay, so it's easy to figure that one for secants, but when we start looking at tangents, what actually happens is we're going to treat the tangent as though it's both pieces. It's going to be the outside and the whole. Okay, so I've got a secant here, so that's going to be pretty much the same. EB outside times the whole, which is EC, equals the outside, EA, times the whole thing, which is still EA. Okay, so the tangent's got a dual roll here. We don't count this because this goes on forever. So that doesn't have a length. We can only deal with this, so we treat it with both parts. And that relates back to this. This is something we did in the first section, actually. We said, okay, now we can say that EB outside times the whole EB equals EA times EA. So if we have EB times EB, that's EB squared equals EA squared. If we square root both of these, we get EB equals EA. So it's just another confirmation that two tangents from the same point are congruent. So let's take a look at some examples. Okay, so here I've got two chords meeting. So I know that the two pieces of this chord multiplied together should equal the two pieces of this chord multiplied together. So x is 4. All right, here we go. We've got outside piece times the whole thing. So it's not just x, it's 12 plus x. Okay, a lot of you guys are going to be tempted to say, okay, well, it's 12 times x equals 15 times 9, but that's not correct. You got to take the outside times the whole thing equals outside times the whole thing. The whole thing here is 24. Grab the calculator here. 15 times 24, I get 360. Here I'm going to distribute, so I get 144 plus 12x. Subtract the 144, so 12x equals, let's see, this would be 216. Let's double check that. Yep. Divide that by 12, and I get 18. So x is 18. All right, here I've got a tangent. So outside times whole, tangent plays both roles, equals the outside times the whole thing. Okay, not just times 12, times the whole thing. So x plus 12. So I get 100 equals, if I distribute here, I get x squared plus 12x. And now I've got a quadratic. When you have a quadratic, make sure you move everything to one side. So I've got 0 equals x squared plus 12x minus 100. And now hopefully I can factor this. If I can't, then I can use quadratic formula. Let's see, how do I get 10? Well, I could do 10 and 10, but that's not going to get me 12 when I add them up. I could do 20 and 5, but that's not going to get me 12. How about 4 and 25? That's not going to get me there. We need to get closer together. Well, I'm not sure if this one factors. Yeah, this one won't factor, so we're going to have to resort to our quadratic formula. So, quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. Our a is 1, okay, coefficient of 1. Our b is 12, and our c is negative 100. So I'm going to have negative 12 plus or minus the square root, 12 squared, which is 144, minus 4 times a times c over 2 times a, which is just 2. 144, so on the inside I've got 144. This is going to be 400, and since it's negative, negative, I get positive. So then we got 544 on the inside. Let's break that down. So let's see, 544. You can divide by 8, and you get 68. 8 is 2 times 2 times 2. 68 is 2 times 2 times 17. So I have 2 pairs of 2's. So that's 4 square root of 2 times 17, which is 34. So I've got negative 12 plus or minus this over 2. So we got, if I can reduce all these, okay, I can reduce all these by 2. So we got 6, 2, and nothing. So I've got negative 6 plus or minus 2 squared root of 34. That's my answer. Okay. So don't forget your algebra tools. Okay, they come into play in geometry too.